Hello everyone. In this lesson, we will learn about the working process of the tractor chassis. In the last lesson, we learned that the function of the chassis is to support the entire machine and convert the engine's power into driving force for the tractor. The chassis includes the transmission system, running gear, suspension system, steering system, braking system, etc. Through the coordinated work of each subsystem, the purpose of controlling the tractor's movement is achieved, ensuring the tractor's safe and reliable operation. Next, let's continue to further understand the specific working processes of each subsystem. First, let's learn about the working process of the transmission system. The transmission system is the collective term for all transmission components between the engine and the drive wheels. The function of the transmission system is to transmit the engine's power to the tractor's drive wheels and power output devices, and to change the tractor's speed and driving force according to work needs, achieving smooth starting, stopping, moving forward, or reversing of the tractor. The transmission system consists of a clutch, gearbox, central transmission, differential, final drive, left and right drive wheels, etc. The transmission route of the transmission system starts with the engine doing work to drive the crankshaft to rotate. Then the crankshaft transfers the rotating power through the clutch to the gearbox, which then passes through the central transmission, brake, final drive, drive shaft, and finally under the action of the drive shaft, the rotating power is converted into the rolling motion of the tires, completing the power transmission from the engine. The power transmission route of the connecting device is that the engine transfers power through the clutch and gearbox, then through the power output shaft to the connecting device. The main component structure and working process. Clutch. The clutch is generally installed between the engine and the gearbox, mainly consisting of the driving part, driven part, pressing device, and operating mechanism. Its function is to disconnect and connect the power transmitted from the engine to the gearbox. When the transmission system is severely overloaded, the clutch slips, serving to protect the transmission components. When engaging, it allows for a smooth start of the tractor. When disengaging, it enables the tractor to stop and change gears without turning off the engine. Clutch working process. The main clutch widely adopts a friction clutch, which relies on the friction generated between the pressing surfaces of the driving and driven parts to transmit torque. Disengaged state. Disengaging the clutch means removing the pressing force on the driven plate. When the clutch pedal is pressed, the release bearing moves forward through the rod, creating a gap between the driven plate and the flywheel pressure plate, thus eliminating friction and disengaging the clutch, cutting off power transmission. Engaged state. When the pedal is released, the pressing spring presses the driven plate against the end face of the flywheel through the pressure plate, putting the clutch in an engaged state. At this point, the hub of the driven plate drives the clutch shaft to rotate with the flywheel through splines, transmitting power to the gearbox. The function of the gearbox is to change the tractor's driving force and speed without changing the engine's torque and rotational speed. Allow the tractor to move forward or backward without changing the direction of the engine's crankshaft rotation, and enable the tractor to stop for a long time or perform fixed operations without turning off the engine. The gearbox is a core component in the vehicle's transmission system, assisting the driver in better controlling the vehicle's speed to adapt to different roads and driving conditions. The working process of the gearbox involves using gears to transmit power. The gearbox contains multiple sets of gear pairs with different numbers of teeth, each set having a different transmission ratio. According to the tractor's driving needs, by shifting the operating mechanism, a certain number of different gear levels, that is gear positions, are obtained, each gear position corresponding to a specific tractor travel speed, to adapt to the tractor's driving conditions. The running gear. The running gear is one of the core components of the tractor chassis, directly related to the safety and comfort of the tractor's operation. The function of the running gear is to support the weight of the tractor and convert the driving torque transmitted from the engine to the drive wheels into the driving force needed for the tractor to move, turning the rotational movement of the drive wheels into the vehicle's movement on the ground. The running gear consists of tires, rims, axles, and a suspension system. Tires are the core part of the entire running gear, with their main functions being to provide support and traction. while also needing to have good shock absorption and body protection capabilities. They are in direct contact with the ground, bearing the weight of the entire vehicle and the force of movement. Rims and axles are the supporting parts of the tires, and their quality and strength directly affect the stability and safety of the entire running gear. The grip and traction of the tires can influence the vehicle's acceleration, braking, and steering performance. The suspension system is an important component connecting the body and tires, with its main functions being to absorb shocks and protect the body, while also improving vehicle stability and ride comfort. The suspension system can reduce vibrations and swaying of the body, making the vehicle's ride smoother and more comfortable. Additionally, the suspension system can protect the body from road bumps and collisions, reducing damage and wear to the body. Steering system. The steering system consists of the steering wheel, steering gear, and transmission rods. The function of the steering system is to convert the force applied by the driver on the steering wheel into a rotational force for the steering gear, which is then transmitted to the steering wheels through the transmission device, thereby changing the direction of the vehicle. This achieves the purpose of the driver controlling the direction of the vehicle's movement. The working principle of the steering system is to change the direction of the vehicle by controlling the steering angle of the front wheels. Generally speaking, a tractor's steering system includes a steering wheel, steering mechanism, steering gear, and transmission device. When the driver rotates the steering wheel, the steering mechanism transmits the turning force of the steering wheel to the steering wheels. The steering mechanism usually consists of transmission levers, universal joints, and links, whose role is to turn the driver's manipulation into corresponding deflection of the steering wheels, ensuring that the deflection angles of the inner and outer steering wheels meet requirements. Braking system. The function of the braking system is to forcefully decelerate and quickly stop a vehicle or tractor that is traveling at high speed. Ensure that the tractor can stop on a slope with a certain gradient, preventing it from slipping down the slope, and work in conjunction with the clutch to safely and securely attach agricultural implements. The braking system mainly consists of wheel brakes and an operating mechanism. The brake, also known as the brake shoe, uses friction to apply braking force to the wheels. The operating mechanism can be mechanical, hydraulic, or pneumatic depending on the type of transmission mechanism. Mechanical operating mechanisms are commonly used in small and medium-sized tractors. The general working principle of the braking system is to use mutual friction between non-rotating elements connected to the body or frame and rotating elements connected to the wheels or drive shaft to stop the rotation or tendency to rotate of the wheels. When the braking system is not engaged, there is a gap between the brake shoes, allowing the wheels and brake shoes to rotate freely. When the braking system is engaged, pressing the brake pedal pushes the pushrod and master cylinder piston, causing the master cylinder fluid to flow into the wheel cylinder under certain pressure, and through the two-wheel cylinder pistons, pushing the brake shoes to rotate around the support pin, with the upper ends separating to both sides and pressing their friction pads against the inner surface of the brake drum. The stationary brake shoes generate a frictional torque against the rotating brake drum, thereby creating a braking force. To release the brake, when the brake pedal is released, return springs pull the brake shoes back to their original position, and the braking force disappears. In this lesson, we have learned that the basic working process of a tractor chassis is one of multiple systems collaborating with each other. The tractor chassis is one of the core components of a tractor's composition. In order to ensure driving safety and vehicle performance, it is necessary to regularly inspect and maintain the various systems of the chassis, timely replace damaged parts, thereby ensuring driving safety and comfort. Please consider the following questions after class. 1. What components make up the clutch? 2. What two parts comprise the braking system? 3. Briefly describe the braking process. This concludes our lesson for today. Goodbye, everyone.